So this is going to be the first chapter of the fourth section of geometry, which is on triangles. And so this is going to be just kind of an introduction to the basic properties of triangles and kind of the stuff to go along with them. So the first and probably most common fact about triangles, assuming you've did them in years past, is that all the angles in the triangle should add to 180 degrees. So that means that if I take any triangle that I draw, like this one right here, and I take angle 1 plus angle 2 plus angle 3, and I add up all these angles, these should all add up to 180 degrees every time. No matter if the triangle's like this, or if I have a right triangle like that, or if I have an obtuse triangle like that, all the angles should always add up to 180 degrees, no exception. Again, this is assuming that we're in the normal Euclidean space and all that jazz there. So you can just operate under the assumption that all the angles in a triangle should add to 180 degrees. And this is actually a theorem called the triangle sum theorem. Um, so there's actually a proof for this. It's actually right here. I'll let you scroll through it yourself if you want to. I'm not going to go through the entire thing because it is kind of a bit long. But again, since it is a theorem, there has to be a proof for it. This is not something we just take on faith or whatever. This is something that we can actually demonstrate as provable and true in every situation. So again, just there for your own enjoyment if you want. But we can actually use that fact to help us solve for missing angles in a triangle. So usually the case is that you have a missing angle or two in a triangle and you want to solve and figure out what it is using that 180 degree trick. So if we want to find the missing measures in, say, this first triangle set here, so we have J, K, M, L. So that set of points there, we want to find out all the missing angles. So we want to find out angle 1, angle 2, and angle 3. So looking at this here, the easiest one I spy here to get would be angle 2 first, right? Because if we look at this triangle here, KLM, we already know two of those angles, and we're missing this one. So what that means here is that I can set up the equation 57 plus 71 plus angle 2 is equal to 180. And I can just solve that like a normal algebraic equation. You can call this x if you want to. You can call angle 2x if you want to use that variable instead. So we add up the angles that we know. So 57 plus 71 would give me 128 plus x equals 180. And then you subtract that from both sides, 28. And you get x is equal to, that'd be 2, be 52, right? Let me just double check that to be sure, but I'm pretty sure that's correct. But I'm paranoid about these things sometimes. So 180 minus 128, yeah. So angle 2 would be 52 degrees. Boom, right there. So angle 2 is solved for. Now we need to figure out angle 1 and angle 3. Well, that's going to be kind of tricky because we know that this angle is 28, but we don't know the other two. So if I were to set up an equation right now, it'd look like this. Angle 3 plus angle 1 plus 28 equals 180. And that's all well and good, but I can't really solve for this because I have two unknowns. Remember, you can't really solve for an equation unless you only have one unknown. So if I knew what angle 1 or angle 3 was, I could solve for the other, but I can't do it if I don't know both of them. But if you see this one here, again, always be on the lookout for these. These are a linear pair. Because again, if I connect the angles here from here to here to here, they make a half circle there, right? Like a little arc there. So that means that angle 1 plus 57 has to equal 180. So angle 1 plus 57 has to equal 180 because they make that little half circle arc there. So this will allow me to figure out what angle 1 is, and then I can use that to plug in this equation to figure out what angle 3 is. So if I subtract 57 from both sides here, minus 57, minus 57, we get angle 1 is, let's go ahead and do that here, 180 minus 57, we get 123. So we know that angle 1 is 123 degrees, and then we can plug that into this equation up here. So I can do angle 3 plus 123 plus 28 is equal to 180. Then again, I combine my like terms, so 123 plus 28, which I can probably do in my head, but I really don't feel like it, is 151. So angle 3 plus 151 is equal to 180. And you subtract 151 from both sides, and you get angle 3 is equal to, well, it looks to be about 29 degrees. and that's your last angle that you're missing there. So always be on the lookout for linear pairs like these two right here, because those linear pairs will help you get at least one pair of angles really quick, and then that will often lead into solving other angles as well. So again, you can only use this little 180 trick if you know at least two of the three angles in a triangle typically. So let's look at the other triangle here real quick. Let me erase some of the stuff. Sorry, I had to yawn there. I don't know why I keep yawning when I talk for extended periods of times. But so if we look at 1b here, we have a lot more angles. Luckily, we have a lot more to work with, though. So even though we have a lot more missing angles, this one might go a little bit easier. Let's see here. Let's see if we can't figure out at least one to begin with. Well, right here in this triangle, we know two of the three angles. So this would probably be a good triangle to start with because we know two of the three. So if I set up an equation here, it'd be angle 7 plus 58 plus 65 is equal to 180. So we'll have angle 7 plus 58 plus 65. So 58 plus 65, we get 123. 123 equals 180. And we subtract 123, subtract 123, and we get that angle 7 is equal to, let's see here, that would be 57. So angle 7 is going to be equal to 57 degrees. Now, from that, we actually get quite a bit. I had to shift my headphones there for a little bit. From that, we actually get quite a bit. So we also know that angle 5 is 57 degrees. And why do we know that angle 5 is 57 degrees? Well, because angle 5 and angle 7 make a vertical angle pair. They make that X shape. So if angle 7 is 57 degrees, that means angle 5 has to be as well. So we know that angle 5 is 57 degrees because vertical angles are always congruent to each other. So again, don't forget to be on the lookout for vertical angles and linear pairs because again, those can give you basically free values essentially. And now that we know that angle 5 is 57 degrees, we now know two of the three angles in this triangle over here. We know that we have a 57 degree angle, a 67 degree angle, and then this angle 4 here that we don't know. So now I can solve for this triangle. So again, once you find one, that kind of leads into the other. So I can do angle 4 plus 57 plus 67 is equal to 180. And solve it through. So angle 4 plus, let's go ahead and solve this here. 57 plus 67 is 124 equal to 180. So minus 124 minus 124, and angle 4 is equal to 56. So now we got angle 4 down. Angle 4 is 56. We know that angle 7 is 57. There. So now we're just left with the bottom ones there. Excuse me. My bad. So once again, we should use our 180 degree trick. So one linear pair I can see here is angle 7 and angle 6. So these two right here, those make a linear pair. Because once again, if I erase the circle I just made there, you can see that angle 7 and angle 6, if I erase some stuff there, angle 7 and angle 6 sort of make that half arc shape again. So that means angle 6, hiccup there, is going to be angle 6 plus 57 is equal to 180. So again, if they're a linear pair, that means they have to add to 180. If angle 7 is 57, that means angle 6 has to be whatever adds to 57 to get 180. So I subtract 57 from both sides, and I get angle 6 is equal to 123. So I know that angle 6 is 123 degrees. Now the trouble becomes, okay, how do I get angles 8 and 9? Because now I'm stuck in a spot where I have one angle in this triangle, 123. I know what angle 6 is, but I don't know the two others. So normally I'd set up like this. Angle 8 plus angle 9 plus 123, which is angle 6, is equal to 180. But I don't know what angle 8 or angle 9 are, so I'm left with two unknowns. However, I do know from these markings right here and right here that they are congruent, which means that they are the same measure. So what I can do is I can replace angle 8 with, say, x, and then angle 9 with also x, because if they're both the same, that means I can use the same variable in each. So basically, since they're both the same, I can label them as both x or both y or both z, whatever variable you want, and then that way I can still solve the problem, because what happens here is I can combine like terms. So x and x make 2x, and then now I'm at a spot where I can solve this again, just like an algebra 1 problem. So again, don't be afraid to or not don't be afraid, but make sure you're on the lookout for angles that might be congruent, because if they're marked as congruent, that means you can use the same variable twice, and then again combine your like terms to solve it through. So in this case here we get 2x is equal to 57, and then divide by 2, divide by 2, and then we get x is equal to some decimal, 57 divided by 2, 28.5. So both angle 8 and angle 9 would be 28.5. So that'd be both for angle 8 and for angle 9. So again, that 180 trick is helpful. All three angles in a triangle should add to 180, but also don't forget about vertical angles, about linear pairs, and about congruent angles that you can, again, mark with the same variable, because those will help you solve through these problems as well. Now, there's one more theorem. Excuse me. I don't know, again, breath issues here. There's one more theorem that we also have dealing with the outside angles of a triangle. So it's called the exterior angle. So this little trick right here, this 180-degree trick that we talked about here and that we talked about here, this is actually called the interior angle sum, because it deals with the angles that are on the inside of the triangle. So it says that the inside angles 1, 2, and 3 add to 180. Whereas we have the other one that we're about to talk about, called the exterior angle theorem. And so the exterior angle of a triangle is always equal to the sum of the opposite interior angles, or sometimes called the remote interior angles. Um, or I guess you could say that the exterior angle forms also a linear pair, linear pair with its adjacent angles. So there's actually two ways you could tackle this. So exterior angles like angle 4 here. Angle 4 would be considered an exterior angle, this angle right here, because again, it's outside the triangle, whereas angles 1, 2, and 3 would be interior angles. So what these two theorems are saying is that angle 4 here, so angle 4, is equal to angle 1 plus angle 3. So it's equal to the sum of the two angles it's not attached to. So angle 4 here is kind of attached to angle 2, right? So it's equal to the sum of the two angles it's not attached to. Or, I should say and or, because they're both happening at the same time, angle 4 plus angle 2 equals 180, because again, they do form a linear pair. There is that little half arc there that you can play off of to solve with. So either one of these statements is correct here. You can say that angle 4 is equal to the sum of the opposite interior angles, again, also called the remote interior angles, or you can say that it simply adds to 180 with its adjacent angle. And again, it just depends on what you had to work with. If they asked you to find out what angle 4 was and they gave you angles 1 and 3, well, then you probably want to use this version. If they ask you what angle 4 was and they only give you angle 2, well, then you probably want to use this version. So again, they're just two tools in your toolbox to solve for an outside angle or an exterior angle. Let's try it for here. So if I asked you how big this angle here, how big x is, well, you'd say, okay, x is an exterior angle. These are the two interior angles that are opposite of it. So x would be equal to simply 50 plus 70, which would make it 120 degrees. And then you're done. Okay, that's what x is, 120 degrees. All you do is you add up the opposite angles and you're good. Same thing here. Angle x is on the outside. Here are the two opposite angles. So it'd be 65 plus 45 is equal to angle x. So that would be 110. Assuming I added right, which I believe I did. And now, again, if they said that if they gave you this interior angle or interior angle instead, so they said that this was like, say, 70, then you could also do this. If they gave you that this was 70, you could do x plus 70 equals 180 and also get 110 that way. But again, it just depends on what they give you. They can either give you the two remote interior angles or they can give you the angle that's right next to it and make a linear pair with it. It's just what situation you have. So there's two corollaries that come from this. So a corollary is basically a byproduct of a theorem, as it says. So it's what you it's a rule or a pattern you come across as you're trying to prove a theorem. So if you did prove the exterior angle theorem, which again, it is a theorem, so there are proofs for it. But in proving the exterior angle theorem, we come across two, again, little subnotes here. One is that the acute angles in a right triangle are complementary, which basically means that if you have a right triangle, the two angles that aren't right, so angle A and angle B here, add to 90. So it says here angle A plus angle B equals 90. That's what this theorem essentially means there. That if you have a right triangle, the two other non-right angles have to add to 90, because once again, the entire thing has to add to 180. So these two have to add to 90. Therefore, when they add to this angle, they make that full 180 again. And then the second one, we actually already talked about this, but you can't have more than one right or obtuse angle in a triangle. So if you have a triangle, there can't be more than one right or obtuse angle. Otherwise, once again, you have too big of an angle, you don't make a triangle anymore because you break the 180 rule, and it all falls apart. So again, these are just two kind of sub things that come off of that theorem there, and they can help us here or there, but just again, good to keep in the back of your head. That way when we start using triangle proofs, these will come back into play. So just make a little mental note of them now, and we'll tackle them a little bit later too. So let's say we have this image here, and then we want to find what angle 2 is. So we want to find out how big angle 2 is right here. How big is that angle? And we know that angle 1 is 38, so we solved that. They solved that for us, so we could say that's 38 there. But I want to know how big angle 2 is. So, okay, the first thing we should do is look for interior angle sum. So look for a triangle that you know the inside angles for, which we do. We know that WXY. So this triangle right here, we know that this angle is 38, we know that this angle is 90, and we know that this angle is angle 2. So we have our situation where we know two of the angles, and we're missing the third. So we can just do our 180 trick here, nothing special. So 38 plus 90 plus angle 2 is equal to 180. Again, just do your normal interior angle sum trick there. So if I add this together, we get 128 plus angle 2 is equal to 180. And then minus 128 minus 128. And we get that angle 2 is equal to 52 degrees. Okay. So again, that one was just a normal, again, you know two of the three angles, set up your 180 trick to find the other one. So now let's go ahead and see if we can't find angle 3. So I want angle 3, which is this angle right here, angle 3. Well, I know that since they're a right angle right here, so you don't see there's a little right angle box there. Since these two form a right angle, I know that if this is 52 degrees, that means this angle plus angle 3 has to add to 90. So I'm just going to set up my complement rule here. Angle 3 plus 52 degrees has to add to 90. Why? Well, again, because I have a 90-degree angle here, and that's made up of both angle 2 and angle 3 put together. So again, they're just going to add 90. So minus 52, and we get that angle 3 is equal to, let's see here, that'd be 38. So again, that was just a complement rule there. And then lastly, we want angle 4 here. So angle 4 requires a little bit of thought process here. We don't know that this is a 90-degree angle. It doesn't say that this right here has a 90-degree angle on it. There's no right angle mark there. So we can't assume that they add to 90, although they probably do. But we can't assume that. So let's go ahead and see what else we can use here. Do we have a 180 trick here? Well, we know that angle 3 is 38. We don't know what angle 4 is, and they don't give us what this angle is down here. So off the bat, it doesn't look like we have a 180 trick. Because remember, in order to do the 180 trick, we need at least two of the three angles in most cases. However, we actually do know what this bottom angle is right here. Because, again, they have a right angle mark here. So if they say that this is 90 degrees, that means this angle here also has to be 90 degrees. Because, again, we have a 180 trick here. So we have, or not, we have a linear pair here. They make a half circle. These two angles form a half circle. So that means that if one of them is 90, the other one has to be 90 because, again, they both have to add to 180 because they make that half circle. So be on the lookout for those half circles once again because they give you sort of free angles if you look carefully enough. So now we end up with a situation where we can use the 180 trick because we have 38 degrees, we have 90 degrees, and so now all that's left is to figure out that missing one there. So 38 plus 90 plus angle 4 is equal to 180. So we add them up here, we get 128 plus angle 4 is equal to 180. Looks somewhat familiar, hopefully. Minus 128, minus 128, and we get that angle 4 is equal to 52 degrees as well, just like angle 2. So this is 52 degrees. So once again, be on the lookout for linear pairs like these two in the middle here, because linear pairs will often give you that missing angle that you need in order to set up a 180 trick for your other triangles. Come on. All right, that's what I thought. So that's it for this video. Again, the key takeaways are that all three angles in any triangle have to add 180. That's the first key takeaway. Second key takeaway is your exterior angle stuff here. So knowing that the outside angle, like angle 4 here, is equal to the sum of the two inside angles that it's opposite from, or that it's a linear pair with the angle that it's adjacent or attached to. So those are the two big key takeaways, the interior angle theorem and the exterior angle theorem. If you can practice and get that down pat, then you're good and ready to go. So hopefully this video helped you out. Once again, let me know if you have any questions. Otherwise, have a good day, evening, or afternoon.